Okay, so let's go jump into logarithms, everybody's favorite function, logarithms. So logarithms basically has to do with, it is the inverse function of what? Does anybody remember? This is a, what kind of function is this?
Exponential.
Well, it's an exponential function, right? So the exponential function and the logarithmic functions are inverses of each other, right? So if I took the log base of a on both sides, I get, right? I get a to the x, or the x now follows in front, right? Log base of a is 1, so it becomes this, right? If I swap the x's and y's to get the inverse function, I get y is equal to log a of x. So you can see that the inverse function, these two are inverses of each other. Right? Another way to do this is I can put this guy in here, right? If I put this guy in here, I get y is equal to log of a of x. The x falls in front. I get log base a of a, which is a, and I'm supposed to get that x, right? Remember we said if it was an inverse function and I put the other one into the inverse function, I would get x. And this is what I got, right? So that's how we would prove that. So the log functions are basically the inverse function of an exponential function, okay? So that's one of the things. What other kind of properties are there for logs that we know? Log of a plus log of a b is log of a times b, right? Then there's log of a minus log of a b is equal to log of a over b, correct? You have that guy. And then we have the change of base. Log a of b is the same as log b of c over log c of a. Change of base, this is the change of base guy. What else do we know? We know that a log of a x is the same as x, right? And these are all well documented in the middle of page 40, and the bottom of page 40, and the middle of page 41. Okay. Any questions so far? This is stuff that we've already known, right? We already know this stuff, right? So let's go to example number 4. Let's see if we can do some solving here. Example number 4. I have solve for x, where natural log of x is equal to 3t plus 5, 3t plus 5, and I'm solving for x. So I do this, right? Why am I using e here? Can anybody explain to me why I'm using e?
Doesn't it go with the natural log?
Yeah, because it's with the natural log, right? Because I have a natural log here, right? So this guy over here becomes x, right? And that's your answer. B, e to the 2x is equal to 10. E to the 2x is equal to 10. So this time I would take the natural log of both sides. Right, so right over here, the 2x would fall in front. 2x natural log of e is equal to natural log of 10. This guy here is 1. So I'm going to get 2x is equal to natural log of 10. Divide 2 by both on both sides. There's your answer. Okay, can everybody see this as being the same as that? Everybody see that? Because this is 1/2 of natural log of 10. If I move the 1/2 over here on top of the 10, it becomes that guy right there, right? We see that? Okay, let's do example number 5. Graph that. Well, y is equal to log 2 of x. That's what we're graphing, right? Log 2 of x. Okay. There you go, right? I mean, and this point is what? This point is 1 because when x is equal to 0, anything to the 0 is 1, right? Because 2 to the 0 is equal to 1, right? So that's where that 1 comes from. Okay, let's see if we can do some applications. The last one, example number 6, finding time. Sarah invests $1,000 in an account that earns 5.25% interest compounded annually. How long will it take to reach 2,500? It's kind of a good lead in because I had almost the same exact question on the test. So we start with $1,000 and we are compounding at an annual rate of 5.25%. I don't know how many years, but how many years later I'm going to get this amount. If I divide both sides by 1,000, I get that. So I have 1.0525 to the t is equal to 2.5. Take the natural log of both sides. The t falls in front like that, goes to there. T is equal to a natural log of 2.5 divided by a natural log of 1.0525. That would be your answer. If you do that calculation, you are going to get 17.9. So almost 18 years. It takes you 18 years to do that. Okay. So that's example number 6. Now let's see if we can do some of the test questions. All right. So let's do number 5 on the test. How long will it take for a population of a certain country to triple if the annual growth rate is 3.6%? So triple, so I start with 1, and I'm growing at a rate of 0.036%. I don't know how many years, and I'm going to get to 3. So divided by 1, I get that. 1.036 to the t is equal to 3. Natural log, the t comes forward. T is equal to natural log of 3 over natural log of 1.036. I believe the answer was 31 years, I think. 31 years. Okay. Example number 6, population of a small country increases at the function of that, where t is measured in years. How many people will the country have after 9 years? You just plug and chug at t is equal to 9, right? The answer was 1,197,217. Number 7. Half-life of an element is 3.2 times 10 to the 11 years. How long does it take for a sample to decay to 3/5? So it's not quite 1/2 year, right? So your answer should be something less, slightly less than 3.2 times 10 to the 11th years, right? So I start with 1, and I have a half-life of 3.2 times 10 to the 11th years. This is the amount of time that passed. Now I'm going to end up with 3/5. Everybody understand why I put it this way? This is the amount of how many half-lives, correct? So if I had one half-life, this would be equal to 3.2 times 10 to the 11th. These would cancel out. I'd have 1, right? 1 times 1/2 would be 1/2. That's the definition of a half-life, right? So now I have this, the 1 goes away. Take the natural log of both sides. So I'd have t divided by 3.2 times 10 to the 11th is equal to, oops, because this came forward, natural log of 1/2 is equal to natural log of 3/5. So I'm going to divide both sides by a natural log of 1/2. Get that. So now I'm going to multiply both sides by 3.2 times 10 to the 11th. And there's my t. That's the time. If you do that, you get 2.36. Okay. Anything else that you guys want me to go over on the test that I have not?